alcohol has like some characteristics to remember. That's a lot here, but I think we'll just choose like, oh, someone's coming in right now. Okay. Hi, Raina. Sounds creepy, right? Sorry. Okay, so I was saying that alcohol has a lot of characteristics. So let's just choose like some of it to remember. So I think I'll go for clear colorless liquid. Okay, and I'll go for neutral. It's pH 7 neutral. And what else? Volatile. Volatile means evaporate very easily. You know, like nowadays we use a lot of hand sanitizer, a lot of alcohol, right? You know, you spray on your hand and after a while it goes off very quickly because of alcohol. It's actually very volatile. Okay, wait, give me a moment. Yeah, what is the form is that? What form is that? Okay, never mind. Okay, so and one more thing. It burns to produce soot-free blue flame. Soot-free means no carbon. Soot means carbon, so soot-free means no carbon. As in no black color smoke, you know, that when we burn something, it produces like black color smoke, like barbecue, like that, you know. So this is soot-free, and it's blue color in flame. It indicates a very clean burning. Usually yellow, red, and orange means dirty. You know, like whatever you burn, like dried leaves, or you burn tree branches, you burn rubbish. That's yellow and red color. Okay, yellow, orange, and red. Okay lah, I think 4 is enough lah, huh? And the users will be probably will go for cosmetics. A lot of cosmetics are made of alcohol base. Medicine, artificial food flavoring. That's the next topic to talk about, which is ester. You remember? Okay, an alcoholic beverage. Okay lah, 3 enough lah. I think okay. Yeah. Okay, so let's dive into the process name called fermentation. So we have 3 types of alcohol. Alcohol is like a big title. We have different types of alcohol in laboratory. So ethanol, methanol, propanol. Okay. I think ethanol is the most important one to remember. Like methanol and propanol is more like a side thing. So maybe you just try to remember ethanol. Then that's it. Boiling point is 78 Celsius. Okay, lower than 100, and the rest followed by 65 and 97. Okay, okay. So fermentation, right? Fermentation, 2 things to remember here. Number 1 is how to explain fermentation and what is the function of the enzymes, yeah, or the yeast that I mentioned. So fermentation is a process of conversion of carbohydrate into ethanol and carbon dioxide by the action of yeast. Yeah, so yeast changes, or should say convert carbohydrate, which is sugar, into ethanol, which is into alcohol. And most importantly is to release carbon dioxide. And that is very important for making bread. Okay, making bread. Wait, I have to exit and enter again. Oh, yeah. Go ahead. Your screen is. Yeah, go ahead if you have screen problem. Okay, so what was I saying? Fermentation is the conversion of carbohydrate, okay, into ethanol and carbon dioxide by yeast. Okay, so what is that in yeast that actually reacts? That will be Z-mase enzyme. Please remember the name of the enzymes in yeast. Okay, Z-mase enzyme. Okay, react on carbohydrate food, turning it into ethanol and releasing carbon dioxide, which is it's more like a specific explanation for number 2 lah. Okay, that's how you produce alcohol. That's it. And you have to remember the equation of alcohol or fermentation. So like very easy, glucose, arrow, yeast. Yeast on top of arrow. A lot of people write like glucose plus yeast. Don't do that. It's glucose react by yeast equals to ethanol and carbon dioxide. Actually, there is water one, but we don't write water. We don't write it out as equation, but making fermenting or producing alcohol by fermentation actually produces water. Okay, but which then we purify it into pure alcohol. Okay, so the picture looks roughly like that. Always they have this lime water. So lime water is actually to test the presence of carbon dioxide. Okay, to test the presence of carbon dioxide. That's the function of lime water. So when lime water, initially it was clear, means like transparent, like water like that. If carbon dioxide is released, right, carbon dioxide will react with lime water, then it turns cloudy. That's the thing you have to remember, the observation of fermentation. Lime water turns cloudy. Okay, and what else? Okay, and lastly, replacement. If we don't have glucose, usually we go for pineapple and sugarcane juice. Very common question to us. Okay, that's it about fermentation. All right, I think we shall try out some question here. So please turn with me to page 26, everybody. Question number 3, page 26. Okay, no problem. All right, shall we? Now, wait a moment. 11. Okay, now, if you realize, right, this is like a combination of Form 5 Chapter 1 and Form 5 Chapter 4. Form 5 Chapter 1 was your microorganism, and we'll talk about temperature. You think you want to make yeast, you think you want to make ethanol, you must provide them the correct condition. If the temperature is not ngam, they don't like it one. So 30 Celsius and 5 Celsius. Obviously 30 Celsius, then they go crazy, they party, they have sugar, okay, they have yeast, and then all the yeast, everyone party. So that's why a lot of carbon dioxide. There you go. Carbon dioxide, you all know the gas, right? So see, you must have everything ready in your head, then your question will look like it feels more easier. Okay. Then very cold, like who party at 5 Celsius? Then they're like not so active. Okay. Not so many people. Then they don't like it. So 30 Celsius, they like it a lot. So they then they release a lot of carbon dioxide. So the carbon dioxide for temperature 30 is more. Okay, like first one. One difference in the result basically means asking for observation. Okay, so like observation is actually what I highlighted for you already. Can you make your own sentence? You have to talk about gas X. Yeah, you have to say, oh, I know. 30 Celsius, gas X is more than the gas X in the 5 Celsius. Can you try to form your own sentence? Yeah, try and form your own sentence. Okay. But as long as I need you to talk about the gas for 30 and 50, 30 is more than 5. So maybe you can, give some adjective to it. I mean, like to say like, how do you measure it? Usually gas, we say like volume. The volume of gas X, okay, collected in temperature 30 is, yeah, so up to you, doesn't matter. I'm just giving you an example. You try, you try. Belum try, belum tahu. Apabila try, Haikal mesti mau. Ayah. You all right? 5 more seconds for you. Then we move on to the next question. Okay, all good. Right. So I'm just going to read you mine. Okay. So I have to follow exactly one. This is roughly. Okay. So what was I saying? Okay. So volume of gas X collected at temperature 30 Celsius is more than volume of gas X collected at temperature 5 Celsius. Okay. I'm still here, by the way. I just changed. I know. Okay, glad that you're fine. Question B, state the responding variable. Responding means, there we just talked about it just now, your observation. So that will be your volume of gas X. Okay, and you all know that the volume of gas X, or I should say the gas X, is actually carbon dioxide, right? So yeah, volume of gas X will do. Okay, like I'm pretty sure you know what is your answer for C, and I'm pretty sure you know your answer for donkey, right? Please help yourself now. Okay, please write the word equation. If you can, please remember and write it down before like you copy exactly. You try and remember it now and write it down and check if it's correct. Yeah, something you have to write on top of the arrow for the equation. Okay, so which food used to replace? You know, the two juices we highlighted in front. So we use the pineapple lah. Butter cannot lah. Where got alcohol made of butter? Okay. So pineapple, you done. Then equation, you're right. So glucose, arrow, yeast, and then ethanol plus carbon dioxide. Okay, no problem. Easy cheesy, lemon squeezy. Okay. Yeah, come. Let's get back to ester, which is to follow on the next formula, or we should say the next experiment. So after you got your ethanol liao, then you will move on. Okay, now I have ethanol. What do I do? Oh, I do ester. Okay, so ester, esterification. That's your food flavoring, or I should say perfume. That's the two uses lah. A lot of things that we makan now are all flavoring lah. You know, very seldom we do original lah, unless you say you cook yourself or you produce your own livestock and all that. But usually when we buy food in packaging, confirm people add food flavoring one. For example, you eat your junk food or your chips when you buy, like, for example, BBQ flavor. You think they really take the chips and barbecue and make the smoky smell and then package it again and sell to you, man? Right? All that are all flavorings, like fake flavorings. So they are called ester, yeah? And to make perfume lah, okay? So this is the equation for fermentation. So, well, it's a bit new words or like more complicated words than before. So take a look. Ethanol, that's your first ingredient. I mean, we have come from making alcohol, plus ethanoic acid. Okay, ethanoic acid. Yeah. So ethanoic acid is called a organic acid because it comes from living. So we don't use those like sulfuric acid, hydrochloric acid. We don't use those. Okay, we use ethanoic acid. Okay, produce ester. Full name ethyl ethanoate. Yes, you're allowed to write ester. If you feel like this is not something you can remember, then it's okay. You can write ester, acceptable as well. Okay, plus water. Yeah, so E plus E equals to EW. E plus E equals to U. Okay, E plus E equals to EW. And on top of the arrow, you add concentrated sulfuric acid. Concentrated sulfuric acid is a catalyst, means something you add on faster. Okay, you add on to make things faster. Like for example, now you stomach pain, right? You're like, oh, you eat a lot of chili, a lot of curry, and then you're like, oh, not feeling good. Well, instead of waiting it to digest and come out by itself, why not let's eat some medicine, like diarrhea medicine, to make it faster, like to let it flush out right now. So you take medicine and then you lucky pain and then you everything out. That's like a catalyst to increase the speed to make it faster. Okay. If we put sulfuric acid only, okay, no, it must be concentrated, because being said concentrated means like very like gao, like I mean like 1 or 2 drops, then it's enough. If it's just sulfuric acid, it could be any concentration, it could be dilute, it could be medium. So must state that it is concentrated. Okay, Monisha? Yep. So yeah, that's the meaning of catalyst. If you remember the equation already, take a look again, yeah? Ethanol plus ethanoic acid, arrow, ethyl ethanoate plus water, okay? Okay, so you have two observations, two things you can observe or obtain from your result. Number one, you will see two layers of liquid are formed. Because ester is like oil like that, lighter one. So ester will stay on top of the water, water will be below. Is that all right? Yeah. So that's the first thing you get to see. Two layers of liquid are formed. Okay. Second thing, you will get to smell something sweet or something fragrant, or we can call like a sweet smell. Okay. But how sweet is sweet? It is like fruits. Okay. And flowers. It smells like fruits and flower. Okay, okay. Can. Okay lah, that's it lah. Easy. That's it. Ester. No problem. Okay, we shall try out the question. Please turn with me to page 28, question 5. Okay, page 28, question 5. Can. Okay, diagram below shows shows one of the tests for alcohol. When a burning wooden splinter is brought near to the alcohol and evaporating dish, the alcohol catches fire immediately. Of course, alcohol is flammable. Name one alcohol that can be used. Like you got 3 types of alcohol. Can you choose whichever you want? I shall say just choose the famous one. Okay. And what is the color of the flame? Remember, just now I highlighted with you, right? Burning alcohol is very clean. What's the color? Like your cooking gas, like that, you know, in your kitchen, your stove, that kind of color. Blue, everybody, right? Blue flame. Is that right? Okay, okay, like number 3, alcohol plus, okay, combustion equation, yeah. So this one I think you all learned like long time ago, like Form 1, Form 2. Combustion equation. So whatever you burn, doesn't matter alcohol or you burn paper or you burn charcoal or you burn whichever, your product is always gonna be releasing a kind of gas that is not good. That will be carbon dioxide. Okay, carbon dioxide. Plus, okay, because this is alcohol, right? It releases water. It releases water. So this is probably what you need to kind of remember. When burning alcohol, it releases water vapor. All right. Okay, question B, shall we? All good. All right. A few drops of concentrated sulfuric acid added to the mixture of concentrated ethanoic acid. Wait, hold on. Look at the ingredient and you must remember what are we doing or what kind of experiment. So let me repeat that again. We are using sulfuric acid. Okay, sounds familiar. And we're using ethanoic acid and alcohol. That's so obvious already. Yeah, correct, Manisha. That will be ester, right? Ester. So we're actually doing an ester experiment, but the picture didn't tell you anything, just some simple instructions. So you must be able to remember. If you don't remember, you're like, huh? This is just another random experiment that I didn't remember. But it's ester, what we just did, without picture, without like details, okay? But ingredient is given. So question number 1, describe the smell. Describe the smell. So remember the smell. It smells like, you have to kind of describe those. So you can write like it has sweet smell like fruits and flower, or it has fragrant smell like fruits and flower. It has pleasant smell like fruits and flower. Because question is being very specific in asking smell, you know, if question is just purely asking for observation, you can write smell, you can write the 2 layers that your eyes can see, you know, that it forms like water and oil kind of, yeah. So No problem. So you can write sweet smell like fruits and flower. Okay, next. What is the name of the group of organic compound? Okay, so group of organic compound that produces smell. Well, this question is just being fancy lah. This is asking for, hey, bro, what are you producing? What are you making there? You know, like the experiment, like, hey, what is the name of the thing that you just produced and there is smell? Like, what is that? Like, what magic is that? So this is just purely asking for the name of the product, Esther. Okay, there you go. Ding. Okay, easy. Shall we? Let's get back to the next part. Okay, okay. Is everyone all right? Okay, so fats, that's the next topic. Now, fats is under organic compound, but actually everything you learn from alcohol to ester to fats to palm oil later to the soap and to the latex to the vulcanized rubber, everything you learn here, right, belongs to this category we learned last week, called the organic compound, because it originates from living things. Like, at least the ingredients are from living things. And the basic elements are carbon, oxygen, and hydrogen, COH, remember guys? Okay, COH. And hence, look at the look at this again. Yeah, elements, COH. Ding. Fats or oil are natural ester. They are made up of glycerol and fatty acids. You know, like last time you learned about digestion. Like protein is made up of amino acid, if that recalls anything. Carbohydrates are made up of glucose, if that reminds you anything. And then we have fats. Fats are made up of glycerol and fatty acids. Okay. Right, so there's two types of fats. There is saturated fat, unsaturated fat. Saturated fat comes from animal, unsaturated fat comes from the plants. Yeah, just basically how we separate them. And it is solid state and liquid state. Yeah, animal fat like chicken fat, you know, those are in like solid state already, right? If it's at room temperature. But plant fat is always in liquid form, right? Here you go. So melting point higher, melting point lower, because it is in solid state already, so the melting point is going to be higher. Okay, it takes more temperature to melt it. But for plant fat, already melted, already in liquid, so the melting point lower. Okay, cholesterol higher and almost nil. Animal fat definitely more cholesterol. I'm pretty sure everyone understand that. And plant fat has lesser or probably no, like nil means zero. Except for coconut oil. Coconut oil or coconut has more cholesterol than other plants, right? Yeah, there you go. So cholesterol is not good. Cholesterol will deposit in the blood vessels that will actually give you a lot of problems. Yeah, unsaturated fat is the opposite. It helps to lower cholesterol in the blood. Yeah, nothing much. This is actually from your Form 5, Chapter 2, which is your nutrition chapter. There is this part as well. Okay, right, then we move on to specifically oil pump or palm oil that we are talking about. So palm oil palm fruit. Okay, quick one. Make sure everyone look at the labeling and the names again. Make sure you spell correctly. The outer layer, it's called the mesocarp. The center is called the shell, which is hard, and kernel is right at the center. Okay, names only lah. So most of the oil comes from mesocarp on the outside. Okay, kernel has very little oil but good quality oil inside. Yeah, shell has no oil, at least not for this, but the Shell station we have lah, but not this shell. There's no oil at all. Okay, there's no oil. Okay, well, oil palm fruit is orange in color when it's ripe, right? That's because of this thing. There's this nutrient called beta carotene, which is a kind of antioxidant. If you heard of, beta carotene is very important for your body. Yeah, so beta carotene is a type of antioxidant. It's orange in color. Anything that is orange or red in color contains beta carotene. you know, like carrot, tomato, carrot, tomato, and all palm fruit, the carrot, tomato. Yeah, see, so many this kind of fruits or vegetables are orange in color, so that thing gives them the color. Okay, so nutrients that we have: vitamin A, E, and beta carotene. Those are the nutrients from all palm fruit. Okay, so usage: cooking oil, soap. There's so much more, but I guess these are the two that we need to remember. Okay, right. So we need to extract the oil. What you're looking at, this is the industrial method. Yeah, in factory industrial method. Okay, the lower part here is your laboratory. Laboratory means the simpler one. So we have only 3 steps. If we do it in science lab, we have sterilization. All right, we have digestion, we have filtration. Okay, if you compare to the top right, what is really different here or missing is sorry, I mean not missing, like extra. We have thrashing, extraction, purification. That's the difference between science lab and industry. Yeah. So thrashing, it's about like separating the fruit from the bunch, like tumbling it so that the fruit will fall off. Extraction is really like squeezing the oil and extracting the oil. Purification is the last step where you want to have the oil to free from any smell, any acid, or any color that you don't want. So it's very similar, but for science lab, it's just very straightforward. Digestion, you boil, kill germs, yeah, kill germs and soften the fruits, okay? Then we pound it, right? Pestle and mortar, we pound it so that we could actually release the shell. I mean, the outer part, the mesocarp, make it soft so it can take off. But the boiling here already makes it soft, and you pestle it, you make it even softer so it can come out easily. Then we squeeze the oil, called filtration. Okay, so basically almost the same steps that we have. Okay, can. All right. So I think we can try the exercise for the palm oil. So please come with me to page 31. Question 9, page 31. Okay, you all can straight away fill up X already. This is your science lab method. You have only 3 steps. Okay, 3 steps. No problem. Okay, so the second one, the pounding one, that's called the digestion. Is that all right? Okay, next will be question B. At which stage the husk means the mesocarp, the outer part, are softened? So according to the above 3 stages, which stage do we soften it? That means you boil it. You use water to make it soft, hot water, boil it. So first one, sterilization. Okay, that's the first one. There we had it in front also, like Coco show you. Number 1, look at number 1, sterilization, soften the fruits. Okay. Okay, number 2, I mean C, when the palm oil is extracted industrially, what stage after GG, if you don't remember the industrial stage, asking for the last stage. Last stage after filtration, isn't it? Take a look again. Here you go. After filtration. So like after filtration is purification. Like if question asks for the function, there you go, but I don't think so. All good? Yes. Okay. Shall we? Can Okay, like 2 parts that produces oil. You can. There's only 2 parts here. There's 3 parts. There's 1 part that there's no oil, ironically. The shell has no oil, but Kernel and mesocarp, yes. Which part has a higher yield? Higher yield means more oil. Remember more, just now we talked about it. More oil comes from the mesocarp. Okay, my friends? Yes, very good. Let's come back to, oops, what is this? Okay, let's come back to making soap. Then you see the chapter is very sequential. And at first we have alcohol, ethanol. After we produce ethanol, then we like, what can we do about it? Let's make food flavoring. Then we do esterification. Okay, after ester done now, okay, nothing to do now. Then we learn about fats. And then after we learn about fats, we learn about oil palm. Why you learn about oil palm? Because that's what Malaysia has a lot, right? We have tons of palm oil. So then we learn, okay, we learn palm oil. Then after we learn palm oil, okay, what can we do? We do soap. Okay, so here we are making soap. It's called the saponification. Okay, saponification. Sapo. So saponification equation is this. All right, palm oil is the ingredient. If you say, can I don't use palm oil? Then what you want to use? Don't use palm, what you want to use? What else? Any plant oil or unsaturated oil, no problem. Like coconut oil, I'm pretty sure everyone heard of, like all your shampoo or your soap we all sometimes see brands or flavors of coconut oil, because coconut oil is very good for your hair, very good for your skin, it's very good for everything. Yeah, you can use any plant oil, not animal oil, okay, not animal oil. Okay, so sodium hydroxide. Okay, this is alkaline. Okay, alkaline. Why? Because the word hydroxide. Yeah, anything in front is possible, like potassium hydroxide, calcium hydroxide. Yeah, whatever lah. And as long as I have the word hydroxide behind, and that's considered alkaline already. That's why soap is alkaline. Soap is bitter. You all tasted or not? You haven't bathed yet. Later you all bathe before sleep, right? Let's say you taste the soap a bit, like you. Then it's bitter because it's alkaline. Yeah. Okay, so palm oil and alkaline we add together, heat up, and then we stir it, and we add common salt, which is the salt that we all makan. Yeah? Common salt function is to solidify the soap and separate from mixture. Well, question will ask you one, hey, what you add? What do you add to make it solid? Or question will ask you, what would you do to get the soap, to obtain the soap? Why do we say that way? Because originally, all our soap comes in a bar form, like a bar of soap, right? Before we had invented all the liquid one, the shower gel or the soap for washing hands one, it was bar, pieces, blocks of soap. Those are the original soap. So you stir everything together, it's in liquid form. The oil, the sodium hydroxide, it's all in liquid form. If you want to get the soap out of this mixture, you have to add salt. When you add salt, salt will make it solid, and you will see some like solid white color lumps floating, I guess. Those are actually soap. So you can actually pick up with your hand and then you squeeze them, and then you feel like, oh, it's soap. It's like slippery. That's how we get soap out of the mixture. The reason why we add salt. Okay, can you understand that? No problem. Okay, so the equation continues with soap. Soap is, like I said just now, like ester. You can write ester, because the full name is called ethyl ethanol. If you don't want to write that, same goes to soap. You can write soap, but the full name is called fatty acid sodium salt and glycerol. Okay, glycerol is what makes soap slippery lah, actually. Okay, slippery. Okay, like fats has oil. Where is it? Yeah, there you go. Fats slippery as well, isn't it? Yeah. So hence, that is the slippery feeling, yeah, from soap. Okay, or from the oil as well. Okay, can. Okay, so then you understand the equation, huh? Take a look again of the equation. So palm oil plus sodium hydroxide, arrow, soap plus glycerol. Okay, then now we need to learn about the soap molecule. Okay, it looks like a sperm indeed. So please make sure you know how to draw. And then the head labeling, it's called hydrophilic part and ionic head. The tail, it's called hydrocarbon tail, hydrophobic part. So actually like that one, hydro means water lah. Phobic means phobia, scared of water. So the tail, scared of water. So the tail, the job of the tail of the soap is to dissolve in the oil or the curry, and then the head is to dissolve in water. Well, that leads you to this one. For essay question likes to ask to explain the whole story for 4 marks, for 6 marks maybe. Okay, so let's say you eat curry and then suddenly curry on your white shirt, you're like, then you have to wash off. Then you throw in the water, you dissolve the soap. So what happens is the soap will do this. The head will stay outside, the tail will go in fact. It's the opposite of like sperm like that, okay? So the tail goes in, the head stays outside. And the tail has a mission. Tonight, the tail mission is to talk to the grease or to the curry to actually make it not so stubborn. You know how stubborn grease and curry is on your shirt. So the job of the tail is like counseling like that. So the tail will talk to the curry like, curry. Why would you want to stick with this shirt? Don't stick with one shirt. There's much more other shirt out there. Don't give up the other shirt in the shopping mall just because of this shirt. Okay, you have so much more choices in the shopping mall. Why must you follow the same shirt? So then the grease or the curry will become smaller and not so stubborn. So the next day when we wash, right, it's easier to come off. That's the job of the tail actually. So the head stays in water, the tail stays in the dirt or the curry or the oil. The tail is to emulsify, it means like counseling, like, hey, don't so stubborn, come lah, follow me lah. Tomorrow, when my master or my owner wash, I bring you to better shirt. Okay, by actually going into longkang, but it was a lie lah, you know. So I bring you to better shirt. Then the curry follow the next day lah. Water is shaken, okay? The head in the soap dissolved in water is carried, so the head is carried upwards. When the water is shaken, then the head must follow lah. The head dissolved in water, then the tail also being pulled by the head, and grease is removed. Ding ding, there you go. Okay, at least you remember like keywords lah. If you can't remember like the whole thing, don't memorize. I would say just remember keywords, important stories. Okay, so everybody, I think we can do the soap question. So please turn with me to page 32 lah, question 11, everybody. 32 question 11. All right, everybody. Okay, see, take a look at your ingredient, palm oil and concentrated sodium hydroxide. So obvious already, it's making soap. By the way, the question did say. But if question didn't, you must like, oh, okay, I know this is called the what's the name of the reaction, my friends? First question, everybody, remember? The process of making soap. Can you help yourself? Okay, it's the saponification. Help yourself, spellings in front. Number 2, write down the equation. Lucky you, half of the equation is given ready lah. You got your ingredient ready ma? Just add on what you need to add on Remember the arrow draw longer You have to write something on top of the arrow of the equation everybody. Okay. No problem. All right, cool. How is soap separated? There you go. Like, what do we do to actually get it? If you don't add that thing, you stir until next year, you stir until COVID-19 gone now, you will also never get your product. Okay, so you got to add something, remember? So there you go. You have to add salt into it. So question like us, how? Very easy, just by adding salt. Okay, so you can write by adding common salt. Okay, by adding common salt. That's it, yeah, by adding common salt. No problem. Okay, like C. Next page, everybody. Okay, when the product is tested with red litmus paper, it turns blue. This one so long ago lah, Form 1, Form 2 lah, but also you know lah, red become blue. What's the meaning? Red become blue means alkali low, right? Blue become red is acidic. So what conclusion can be made? See, I told you just now, the soap is actually made from sodium hydroxide, and I did told you it's alkaline, right? So, and I said you should try out the taste. It tastes bitter. So conclusion means soap is alkaline. It's as easy as that. So you have to write soap is alkaline. That's it. Okay, soap is alkaline. Alrighty. Okay, like you write down the part of A and B, part, you know, the hydrophilic, hydrophobic thingy. Okay, so please help yourself. And question E, please arrange the sequence of action of soap on the curry that we talked about just now. You might not see exactly the same words, but you can kind of guess like the story already. Okay, so like help yourself for the A and B and write down the sequence. All good? Okay, let's check out the sequence, yeah? So we should start with, I think, Z, clothes are brushed with the soap solution. Okay, just the A, right, we write hydrophobic part. Yeah, the hydrophobic and philic part. No need write the head and the tail. Write the name of the part, okay? Yeah, so A is the tail, hydrophobic, and then B is the head, hydrophilic. Okay, okay. Okay, so I was saying that Z is the first one. Clothes are brushed with soap solution. Okay, followed by Y, tail of the end of the soap buried itself in the grease, so the tail goes to the grease. Okay, followed by W, surrounded by soap molecule, and then followed by X, soap and grease are lifted from the clothes. Of course, it's not a complete sequence, but those are the hints that you can find out. Okay, noise, like we have rubber, the last part. Actually, I'm pretty sure everyone is very familiar with this. Okay, like everybody, long story short, yeah. Rubber, it's called latex, natural rubber, it's called latex. The monomer, it's called isoprene. I'm pretty sure you remember that. Okay, you know, like protein is made of amino acid that I mentioned just now, like fats made of fatty acid and glycerol, starch, or we say carbohydrate made of glucose. So same goes to this. Rubber is isoprene. Okay, it looks like that. There's a lot of negative on the outside. That is what makes it repel each other. Yeah, after the rubber is being tapped from the tree, it remains in liquid form because the negative and the negative of each molecule actually bounce each other off. They will not break up and combine. Yeah, so it sticks together. Okay, all the negative protect each other from colliding. So there is two things that we will do now. Either some factory wants you to provide the latex in solid form, like maybe shoe factory, Shoe factory needs to make the shoe sole. And also maybe factory like car tires, they need solid rubbers. So you need to provide them. So hence we add acid lah. So please remember the name of the acid. Formic acid, acetic acid, ethanoic acid. Okay, so when you add acid, right, you are actually adding positive hydrogen ion that will neutralize the negative on the outside. No more negative, no more protection. Then they collide, they break, okay, and they combine, and latex will coagulate. That's the function of adding acid, to make it into solid. Okay, if some factory like, I don't know, hand gloves, like surgical gloves, or like a condom factory, they actually want liquid, the latex to be in liquid form forever. So then that's when you need to add alkaline, which is ammonia. Only one type ammonia, but acid got 3 types. Okay, when you add ammonia, which is the alkaline solution into it, you are actually adding more negative to neutralize the bacteria, because bacteria will go in if you don't do anything about it, right? Bacteria will actually spoil and digest the latex. So bacteria will actually create positive charge because they produce acids. So when bacteria is in it, right, bacteria like hey, yum, 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 and then they throw a lot of positive, then the membrane will lack of negative charges because they neutralize, and then they collide, and then boom, then they collide, then they form a solid latex, which we do not want because we want it to be in liquid state, right? So hence we're adding ammonia, we're actually adding more negative to it to protect the membrane. You eat lah, you nom nom nom, you want nom nom nom, how many? I also throw a lot of negative, so we fight. You throw positive, I throw negative, you throw positive, so we keep throwing a lot of negative, which is ammonia. Okay, so then sometimes if you think like the normal rubber is not good enough, we make vulcanized rubber, right? By burning or heating with sulfur. Okay, so when you heat with sulfur, it forms vulcanized. It forms cross linkages like that. Okay, this is what we do in science lab lah. I mean, sorry, in factory lah. This is industrial. Okay, in school we do this one. Soak in sulfur monochloride solution. If we all burn rubber with sulfur in science lab, right, you and me will go to somewhere very far and will never come back, I tell you. So you can never do that in science lab. We should only use this solution, less dangerous. Okay, then it becomes vulcanized rubber. It's a stronger version. Okay, so what happened when you burn with sulfur is that it forms cross linkages. I'm pretty sure you still remember this this term, okay? Cross linkages prevent rubber polymer from sliding onto each other. Okay, before that, if don't have, then it will start a very easy one. But now with it, right, it actually holds each other, so it becomes stronger. So basically, this is like Tony Stark having his Iron Man suit. He still can die because he's human, you know, but he has something extra to protect him. So natural rubber is like Tony Stark. Making vulcanized, right, is just adding some protection to it. Yeah, so it makes it stronger, harder, more heat resistant, and harder to stretch, more elastic. So vulcanized rubber are harder, you know, compared to natural rubber. Okay, okay, like we can try out the last question. So please turn with me to page 37. We try out the elastic experiment. The vulcanized rubber becomes stronger one. Okay, lie. So we want to test on 2 rubbers, natural rubber and rubber soaked in sulfur monochloride solution. There you go. See, if you don't know this is a science lab method, you might be thinking, hey, I thought burn with sulfur one. Why like that one? Hey, I don't know, don't want to do. So you have to know like, okay, this is actually another way of making vulcanized rubber. Okay, so there you go. We clip the weight onto both. We will measure how long it extends after the weight is being removed. So vulcanized rubber is harder. It will not extend so much, or it will go back to original state one, right? Natural rubber, you extend few more times, then it becomes longer already, so very lousy. Okay, so like hypothesis, now we are testing about what? We are testing about elasticity, right? So obviously in this question, we want to see which one more elastic, but we all already know that vulcanized is more elastic. But you know, this question you have to act like you don't know which is vulcanized, so you copy exactly this one. Rubber soaked in sulfur monochloride solution is more elastic than natural rubber. You act like you don't know, but you actually know this is vulcanized. Okay, this is vulcanized. Yeah, so everyone, please start off your sentence. You can write rubber that is soaked in sulfur monochloride solution is more elastic than natural rubber. Okay, more elastic than natural rubber. Is that all right? Okay, like next one now. Can, no problem, everybody. Okay, like constant variable, something must be fair here. No matter I use natural or I use the vulcanized, something must be fair, right? That is the mass of the weight, yeah? Mass of the weight. If it's 1 kg, 1 kg. 500 grams, 500 grams for both. Manipulated, see, I'm testing both types of rubber. Yeah, so manipulated will be type of rubber strip. Okay, type of rubber strip. Okay, nice. The next one. Okay. In this experiment, what happened to the vulcanized that is soaked? There. Just now we act like we don't know like that, but actually you know, we are actually making vulcanized. Well, question asking, what happened if you soak in sulfur monochloride solution? When you soak in sulfur monochloride solution, what happened? Sulfur atoms from cross linkages. There you go. So I think actually you can straight copy from this one. Okay, so you can write sulfur atoms form cross linkages among the rubber polymer, and you can actually continue with become vulcanized rubber. Okay, so you'll copy from here to here. Then you'll add on to become vulcanized rubber. Okay, to become vulcanized rubber. Okay, all good. So sulfur atoms form cross linkages among rubber polymers to become vulcanized rubber. Nice, everybody. Last question. Tricky, a bit tricky. I was also thinking like, what is the example of vulcanized? I'm like, oh, okay, car tire, okay. But asking for natural, okay, car tire definitely, no, this is vulcanized. Boots are made of synthetic, like man-made rubber in Form 5 Chapter 7, if you remember, synthetic. So this is a pacifier for baby. Pacifier is the rubber part that they chew, that's natural rubber. Okay, Ken? So this is the answer. Alrighty. Cool, my friends. We are done of chapter 4.